Some IDS systems, intrusion detection systems, generate random IP IDs because I don't know what's dependent on this IP ID on the network. So randomizing IP IDs may help protecting system. But also, if you see randomized IP IDs in responses, this definitely presents you that the receiving party has intrusion detection system running. The second parameter I'm checking is TTL. When I send outgoing packet, the TTL equals 128. Let me draw the diagram. Say you have 4 routers in this network. 1, 2, 3, 4. And 2 clients, such as Alpha and Bravo. When Alpha sends the packets to Bravo, there could be multiple ways for packet to come to Bravo, such as 1, 2, 4 Bravo or 1, 3, 4 Bravo. Could be even worse, 1, 2, 3, 4 Bravo. This is kind of complicated stuff, and this is something router decides what's the best way. But sometimes the packet goes to a loop, such as 1, 2, 2, 3, and then 3 decided to forward this packet to 1, and packet goes to loop. To prevent looping, TTL is employed. When the first router just simply receives the packet, first it decreases TTL. Still not 0. Okay, now we can calculate the path and forward packet via this path. So TTL may help you figuring out how far is your victim, or maybe how far you're in the victim network. So response which came from 1020.0.203 indicates TTL equals 127, which points to 2 facts. First one, most probably this is Windows, not Linux. Linux may have 64 default TTL. And the second, that the victim is 1 hop away. So the networks 172.20 and 10.20.0 are directly connected with a single router. So this is what I see from TTL. Again, this is not guaranteed, but in most cases, it indicates that 128 stands for Windows and 127 indicates 1 hop away network. Is it clear by the moment? Please also note that you are required to know, for the purpose of exam, the types and codes of ICMP messages. In this case, when you ping somebody, echo request stands for type 8. Reply stands for type 0. So please find it in your traffic. And that's even more. Let me describe the encapsulation idea. What you see in this piece of traffic here is multiple encapsulation of data. What you see like ABCDEFG is the payload of ICMP. So this one is ICMP payload or ICMP data. It has some parameters such as identifier, checksum, code, type, so header. Sometimes there is the trailer. In this case, trailer doesn't exist, but header. So this one should be ICMP header. This data is encapsulated into IP version 4 packet. Which encapsulates IP version 4 payload and also represents some header, IP version 4 header. And all of this is encapsulated into Ethernet frame. So this one is Ethernet frame, which also has frame header. What's inside is frame payload and there is also the trailer. Basically frame checksum. In general, you see that data has multiple encapsulation layers. ICMP is very simple example. And when network card accepts the frame, so network card works on frame level, it analyzes headers and it states that, okay, packet was sent here by this MAC address to this MAC address, and IP version 4 is encapsulated inside. And what you see as hexadecimal 800, which indicates that IP version 4 is inside. So network card unpacks the frame, drops the header and trailer, and delivers this part to IP version 4 translator, to IP version 4 engine. IP version 4 engine unpacks one more package. This is exactly what you received from Amazon or eBay. A packet inside the packet inside the packet. But some packets were opened by DHL, some packets were opened by MSC, Mediterranean Shipping Company. Some packet was unpacked with check post and so on until you receive your final package. So IP version 4 translation system unpacks the data, identifies headers and payload. It states that there is ICMP data encapsulated inside. So IP version 4 delivers this part, encapsulated part, to ICMP language model, and ICMP language model operates this data. Also unpacks the packet, analyzes headers, and processes this data, this payload. For ping, the payload equals padding. Padding means nothing, just stuffing with something to the minimum length of the packet. So padding does nothing, just simply, again, it packs the packet to the minimum allowed length. And in normal ICMP, you see A, B, C, D, E, F, G. Sometimes you may have zeros in here, such as 0, 0, 0, 0, 0, 0, 0, hexadecimal zeros. But if you have something intelligent in here, you are hacked. Because this is unintelligent in some way. This is the legitimate payload, which is just simply just bullshit. There is no commands or user data inside IP address, nothing else. Well, I see this is a little bit complicated. I will perform trace route and may have some big break. I will begin sniffing from scratch and also prepare trace route. The command may look like this: tracer -d, which means do not perform DNS, no DNS, just simply ICMP, and this is it. -d 8888. So I will figure out my path from this virtual machine to Google and all the routers in between. So I begin sniffing once again. I begin trace route. No, 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 no. This is the virtualization issue. Okay. I don't have Wireshark on my physical machine, but I'd like to show you the result. Trace route, trace route, there's D8888, go. That's the good picture. What's bad about my attacker machine? I don't want to switch it to the real network, but I will try. Okay, this is demo, maybe just for me. Oh, you could try. Okay, you could try. So, bridged adapter, I'm connecting via wireless network on my physical machine. Yeah. So I begin sniffing and begin trace routing 8888. Now stop, and I'll switch virtual machine back to internal network, to CHLAN. Okay. So let me explain the idea. Yes, filter ICMP once again, because trace route is performed based on ICMP packets. Based on ping. So I am trying to ping Google with specific parameters. And the first parameter is here. TTL equals 1. So the very first packet is issued to Google with TTL equals 1, and the very first router decreases it to 0, figures out it's 0, and drops the packet. Basically, it's not dropping the packet, it returns the packet. And that's why I know the IP address of my next hop router, because this router returns packet back to me, this one. The next attempt is basically here. I'm pinging with TTL equals 2. So my neighbor router decreases by 1 and passes by. The next hop router decreases to 0 and stops processing this packet. And this packet is returned back to me. With specific message, TTL expired in transit. And I can see my packet attached to the response. But again, the idea is that every time I ping my end destination with TTL equals 1, TTL equals 2, TTL equals 3, and so on, until I have reached my destination. And this is how I figure out, based on responses from routers. Routers are responding back to me that I failed. Based on those responses, I figure out the path to Google from this virtual machine. Why this could be important? Very simple. This is the building, multiple store building, and this is you, or maybe this is you, whatever. You attend this building, you navigate to server room, you inject your device, you connect your device to the local network, and go away. Walk away. This device establishes connection to outside to your location, and by using traceroute, you figure out how deep into this network you are located. One more scenario. There is an office building, many computers. You send an email message with a Trojan, which also contains command line or shell. The Trojan establishes the connection to your machine. You have control over this Trojan, and you never know how deep into the network you are located. So you perform traceroute to outside. And by this, you figure out how many hops away are you from the external location. How many routers are there within the victim network. So this could be done by device, by malware, and so on. Or you just simply need to figure out the path to all the divisions of this company. So you will trace route and you will see how to build this network in GUI, like you see on victim machine. This picture could be built based on responses of traceroute. By the way, Jude also recommended for attackers to build the network picture. It could look like MikroTik viewed and say images like this. Yeah, this one is a good one. Picture. Very good picture. So you see the connections between switches, routers, hosts, and so on. So you build a detailed picture of the network. Any questions so far, please? Somebody? Come on. All right. So let's have a big break, like some 50 minutes. Is it okay for you?
Yeah, sure.
So let's get back at 1:30 Praga time. Okay, see you.
Okay, thanks you.
You okay? Doing good? Any questions? You here?
Good afternoon.
I see. So you're alive.
Yeah.
This looks good. Okay, that was the very beginning. The simplest part. Any questions so far, please? No. All right. Let me check what else we have in here. So trace route, it's done. Yeah, that's the idea of trace route depicted on the screen. Like if you somewhere deep inside a company. So how do you figure out if there is something in between you and the victim, such as some firewall or intrusion detection system? It's like you might find that some IP addresses it's not here, maybe repeated, and then this could be something which shows you to the work of the firewall or maybe IDS. So if you perform trace route to the end system and on the same IP router responds you back for 2 times, this is not normal. Well, talking about email communications, let me show you a few simple tricks about email. It's not necessary to work as any other technique, not guaranteed to work, but in many cases, this is very possible. So let me show you some part of my email. This may take a few minutes. I will go to my email and find few specific messages. A second. Okay. There are a lot of messages with different kind of. I want to show you, for example, this one. This technique typically works in many cases, so it's not necessary to work like 10 years ago. It still works. This is an invitation to Windows 8 IT camp. I have saved this message on purpose because it was so special to me. Just simply Microsoft Latvia provides some seminar for IT guys, some training in some address in Riga, and if you want to be registered, you just simply click here, and let's check what's inside. Copy hyperlink. So that's the link to the event registration. Very simple. So you're identified by this ID, but that's not it. This is just simply to accept the invitation to register your attendance. But if you check the source of the message, right-click View Source. If you check it carefully, you'll find something even more interesting, such as this one. Some picture embedded into the message with reference ID and width and height of the message 1 pixel. And this is pixel, just a pixel without borders. So you basically never recognize it on your screen. This is just a pixel. In HTML, message downloaded from outside source. And the result that they know that I have read the message. They know specifically that that was me. Well, how it works in virtual machines. If you go to web server, if you navigate to Microsoft IIS, and this could be administrative tools, Internet Information Services. So you see that there's the website. I'm doing this quickly because you don't need to repeat this exercise. This is just to show you that it happens, it takes place. So PowerGym website, it has login module. So system drive inet pub logs log files. Let me check this folder. Inet pub logs log files, and this is this web server instance. Well, I have navigated to this website today. So I see the addresses and requests. Now, this is a dude. This is just a monitoring from dude that everything works. But this could be a little bit different, such as the client. Unfortunately, I have navigated to my own machine, to localhost. But okay, so there could be the client IP address. There's the client IP address. There's the client user agent, which describes Windows NT 6.3, which stands for Windows 8, 64-bit. And it also presents you the Chrome version. You could try different browsers, you will see the different user agents and what specifically was requested. Like this script. I have searched something in trainers, and that specific request I have searched for Alex Doe. So basically what you are doing is logged in log files of the web server, including your IP address, including your user agent string, such as operating system and browser version. Well, so you could do what? Specifically craft your email message and send to your victim together with this type of embedded picture, single pixel. And if you build the message in a good way, in an interesting way, so the victim will click download pictures, so you will find out some information about your victim, such as web browser, operating system, and IP address, external IP address. If say what? So that's the company. That's the attacker website. You send the specifically crafted message, and say office manager clicks on the link. So by this, exposing their external IP address from here. Or say if some manager moves around and logs in from their laptop from home network, and let it be like the network without VPN. The VPN connection is not established yet, but nothing stops you to read an email message from Office 365, for example, Microsoft 365. You read the message, you click download pixel, and by this, they expose their external IP address of their home office, or maybe one more location. So this could also be a way of collecting IP addresses of your victim and the information about their operating systems and email clients sometimes. Let me show you one more trick. So back to my messages, to my email, and say I have more messages saved somewhere here. Let me check which exactly I would like to show you. Maybe this, no, this one. File properties. Don't that. Well, okay. Also could be good source of information. A guy from specific company, Latvian Telecom, dropped me the message. And what I see from this message, his Active Directory domain name, his mail server. Oh, no, this is his workstation with internal IP address. What about his email server? I need to browse for more examples, but I know exactly this is his workstation name within Active Directory and the IP address. Maybe some more messages. Give me a second. Yes, this one. This is something I've missed from previous message. This one. This is the workstation. That's mailbox, MBX mailbox. This Exchange server. So Exchange server on premises. It's not necessary to work on other messages. This is just the general idea what you could do with email. Just simply, yeah, one more business case. I was working for some company. I was sysadmin, and some employee dropped the bad message to our local Latvian website, which was called just simply like bad reputation.lv, and where users tend to leave their reviews of bad companies. And the user from our company dropped the message that this company is shit and a lot of bad words. I was asked to figure out who was that. To post something on that website, you need to drop your, you need to authenticate with your email. So the email was something like someone at Latvian public mail provider inbox.lv. So I have created my faked account on inbox.lv, such as here at inbox.lv, and send the message like, thank you for your review. I was about to join the team in this company, but now I understand this company is very bad and will not join anymore. So thanks for your review. Thank you very much. And the person responded, you're welcome, something like this. Cheers. And based on that response, I have figured out the computer name of this employee. So that's the result. So I just simply drop the message, thank you, received response, you're welcome, and analyzed headers. And this is exactly what they say in this slide. So you could track email communications by analyzing the properties of the message. You will have this as your homework. You will see it in your labs. using Malt-Ego and Recon and G. So I'm skipping this at the moment, as well as Foca. This is your homework. You will see it in your material and in labs. Countermeasures. What are the recommendations to minimize your footprint in the internet? Well, I don't know what's that. How do you configure web servers to avoid information leakage? This is bullshit. But basically, this one is a good recommendation. Limit the amount of information published on the website of the company and private sources and what you publish about yourself, your kids, your business. Just simply limit your publications. It's not necessary for everybody to know that you have earned $1 million or something. You know, typical attack example, like you publish on the web, on Facebook, pictures from your vacation for example, in Dubai. And thieves already know that you are not at home, not home. You're just simply not home. And they could try to break into your home because you're not here. Very simple. Say this one is quite disputable because if you deny the connectivity to Facebook or LinkedIn from your enterprise network, users will do it from their mobile phones. So when they utilize company computer to connect to Facebook, basically, okay, it's not fair, it's not legal, but you can spy on them. You can record screens, you can save keystrokes. Okay, attacker can do that. Attacker can control their connection to the social networking. If the company totally prohibits connection to Facebook from computers, users go out of control. That's my point of view. Sometimes, and again, I don't know if this is good or bad. I never claim to be the good guy. Sometimes we have the requests from the top management, like, could you please watch carefully on this guy? Could you please check a few screenshots, maybe check his messengers, like who he is communicating to. So this represents some opportunities to spy on users for some specific reason. And sometimes this is reasonable, very reasonable. Well, I'd say the suggestion is to have the dedicated person who is permitted, who is authorized to publish information on the web. And sometimes it's quite useful to perform discovery about yourself, about your company on the web, to figure out if there is some leakage. The next module is scanning networks. There are several objectives what we do in scanning. First objective is to discover live hosts. If you connect your device, hacking device to the network, or you have infected somebody's PC with malware, so the question is, what's around? How many computers, printers, TV sets, IoT devices, wireless access points, routers, switches are connected to the same subnet, to other subnets. So we discover live hosts. This is the first. We discover IP addresses of those hosts. The second step, so this is not here. The second step is to discover open ports on those hosts. So step number 2. And this is also sometimes challenging because if they have the local firewall or SIEM system, so they may catch you and block your activities. Or sometimes even more interesting, they could present you the honeypot. An attacker is totally busy with the honeypot, not paying attention to the real network. So that was the first step. That's the second step, to scan for open ports. And you need to understand that every open port represents some application. So then you discover services running on those ports. What applications actually keep those ports open? And then you could try discovering vulnerabilities in those services when services are totally identified. So let's perform first simple exercise of live host discovery. Please go to attacker machine. On attacker machine, first, please disable Windows Defender. So you click Start, you type Defender, and perform 2 actions. First, you need to disable real-time protection. And second, add your hacking tools to exclusions. Let me show you how to do this. First, I'm going to Settings and select to disable real-time protection. Was it hard? So once again, in case somebody has missed this, I'm clicking Start, searching for Defender. In Defender, I'm going to Settings, and then I'm going to real-time protection and turn it off. That's the very first step. The second step is to add exclusions. Exclusions are here. Please add all 3 disks to exclusions. So you select exclusion, the root of the C drive. Oops, it got closed. I'm going to exclusion once again. Yeah. So I select folders and exclude the root of the C drive, of the E drive and F drive, because this is the attacker machine, not victim. And please tell me if you succeeded.
Oh, yes, I got it.
Success.
Thank you. The next step is to install hacking tools. This Windows 10 comes with Kane tool installed, but it already was removed by Defender. So to reinstall it, you say Kane. It was deactivated by Defender. So I'm going to Explorer and navigating to this PC, here tools. Now please tell me if you have managed to mount peer tools and CH tools to your virtual machines.
Oh, yes.
Maybe someone needs assistance, just tell me, because we will work with tools quite closely. So from peer tools, Now I'm going to peer tools. I'm going to packet capture folder. In this folder, I will reinstall Kane enable application. So the full path is on my screen at the moment, was on my screen. So it's in peer tools disk, packet capture Kane. It's very simple. You click next, 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 and then it may ask you something interesting. And let me explain what's that. Tell me when ready.
Yeah, ready.
So it asks you if you want to install WinPCAP, PCAP packet capture engine. So there are multiple engines such as WinPCAP, a little bit older, designed to sniff traffic on Ethernet networks from the cable. EarPCAP, designed to sniff traffic from wireless cards. You need EarPCAP compatible card. NPCAP, next generation PCAP. You could download it from their official website. That's the actual engine of sniffing traffic. And USB PCAP to sniff USB. Basically, we will work with this one with PCAP because Kane is compatible with PCAP. So it says not supported. No. It's already installed. Should be already installed. Let me double check. A second. I'm going to control panel, double check. Otherwise, I need to install npcap. Oh yeah, I understand why. I took this image from EC Council, this image of Windows 10. So I haven't installed it myself. So that's why. Some old version of npcap, this is good for Kane. Okay, so Kane should be reinstalled already. Let me double check. Yeah. So let's synchronize all together at this point. So run Kane, and let's do it all together.
Ready.
One,
Ready.
Yeah, ready.
second, 3, 4, 4. Somebody else as well.
3.
5. Okay. So first, I need to switch network card to promiscuous mode. It's here. I will explain what's that just a little bit later. In a minute. Then you go to Sniffer tab. If there is some results, just remove them, remove all, and click plus. And then scan the local subnet. So first you enable promiscuous mode. Second, you go to Sniffer. You also make sure that you're on host sub tab. Then you click plus. And then you click OK. Just make sure that the range displayed here is the same range you are in, 172.20. That should be your subnet. Then just simply click OK, and it will scan all the hosts and present the result. So in this network, we have 6 hosts. Attacker itself it is not in a list. So the attacker has the IP address of .10. But it should be stupid to attack yourself. So there are 5 victims in this subnet discovered. One of them, 100, is your Kali. So actually not a victim. So you never attack yourself, you don't attack Kali, and still you have 4 victims, 4 hosts in this network. Windows 7 domain member, just simply standalone machine, domain controller, and the router. Router is also a victim. This is it with this tool at the moment. We have just simply discovered the current subnet. Now we go to Kali. Yes, I suggest you deactivating promiscuous mode for the moment. So now Kali. In Kali, you need command line. Okay, in command line, we will call nmap. And we will perform so-called ping sweep -sn. And I will nmap my current subnet 172.20.1-254. So that's the range of IP addresses. This is it. Okay. You could also nmap the second subnet, but at the moment that's okay if you discover the structure of the local subnet. But basically I will do it for remote subnet as well. So nmap -sn 10.20.01-254 go. All right. This may take some time because it's performed via slow router. But as you might see, few more hosts are discovered. So we have 10 IP addresses, 10 hosts. Okay, considering the router has 2 IP addresses, 9 hosts discovered in this subnet. No, in 2 subnets. So could you present the same result? Any assistance needed? Please tell me. Good. 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 So I see you're good. Well, now let me explain the idea of Ethernet frames, MAC addresses, and scanning hosts in the local subnet behind the firewall. For this exercise, I'll do what? I'll select attacker machine. I'll utilize just simply ping. And I also need, say, client machine, which will be protected with the firewall. So I'm going to network settings, right-click network, open network sharing. I'm going to change adapter settings. Oh, no, not adapter settings, just right behind firewall. And configure firewall. Everything is blocked. Everything, just simply everything is blocked. No any connections accepted. I'm totally blocked. At the same time, I will launch Wireshark and we'll try to ping. In your case, it's not necessary to repeat this exercise, but if you can manage to do this, that's okay. So I'm sniffing network. I'm pinging 172.20.8, enter. Pings never work, which means computer is not on. But let me show you the output in Wireshark. So let me remove, so not HTTP, remove unneeded traffic. Not this one. Okay. ICMP. This is my machine, .10, communicates with Windows 8. Still a lot of trash in here, so I will do it like this. IP.address double equals 172.20.8. Maybe this is going to be a little bit easier. Ping request, ping request, ping request. Ended in nothing. Also, dude tries to ping, and also the expected result is nothing. If you switch to victim machine, you will see that it will turn red in a minute. Currently it's green, but it will turn red in minutes anyway, because it's not supplying pings anymore. Well, and now I'm switching to ARP protocol. And that's the result. Let me check. 2 packets, those packets. So I'm focusing on those 2 packets, broadcast and reply. So I'm broadcasting, my Windows 10 machine is broadcasting ERP request. Who has 172.20.8? Please tell me. And 172.20.8 is responding, even though firewall is on. Now let me explain the idea, why it works, and why I still able to find out that this host is alive. I will draw it on the screen. In local subnet, when there are 2 hosts, Alpha and Bravo, in local subnet, computers communicate using MAC addresses, not IP addresses. IP addresses are designed to cross the subnets. So in local subnet, before communicating, computers need to figure out their MAC addresses. And this is how Ethernet frame is built. Let me show in Google, basically. So Ethernet frame. The structure of Ethernet frame. Let it be this one. So preamble is just a noise. So this is 8-byte noise issued by the sender to others to figure out that the communication will begin. So noise, I typically never count as the part of the frame, just simply noise. But okay, if according to documentation is here, let it stay. Basically, the frame is here. Frame consists of few fields. Destination MAC address, 6 bytes. Source MAC address, 6 bytes. Type or length. And definitely this is type at the moment. And this is what you saw in IPv4 communication. 800 hexadecimal stands for IP version 4 encapsulated into data. So in most packets you will see in Wireshark, there will be type 800. Then some data, and then checksum of the frame. This is not any security measure. No, not encryption, not hashing, just simple checksum. To make quick check if all bits are correct. Still, this is not some code such as error correction code. No, not error detection code. Just simply checksum of all bytes. But we need to pay attention to this part. So frame must contain the destination MAC address and source MAC address and encapsulated data. When you type, for example, in this example, you type ping bravo, IP bravo. So alpha, on alpha command prompt, you type ping IP bravo. You cannot do it by IP address. First, you need to perform MAC address resolution. So the first frame which is delivered to the network frame is MAC alpha. No, the destination is broadcast, which stands for FF. The source MAC address, MAC alpha. Type, data, everything inside, but the payload actually is who has IP bravo, please tell IP alpha. Yeah. And the second frame generated by Bravo. So MAC alpha is the destination. Source is MAC Bravo. And the data encapsulated in ARP protocol stands for IM IP Bravo, MAC Bravo. So the first frame was the broadcast to everybody. The second frame is unicast, delivered to alpha from Bravo. And you cannot prevent this traffic from happening. So again, this is ARP request. And this is ERP response. You cannot prevent this traffic. There is no firewall which blocks this traffic, as per my knowledge, because firewall works on IP level and up, not on layer 2. If you block layer 2 communications, if hosts will be unable to resolve MAC addresses, the traffic will not work at all. No any traffic will pass. So that's why you also see that the router, for example, the router tried to communicate with Bravo, okay, because of the software they do. But if Bravo is blocked from ERP protocol, Bravo will be unable to resolve MAC address of the router, and router will be unable to resolve MAC address of Bravo. And then the communication will be totally stopped. Next frame. So destination is MAC Bravo. Source is MAC Alpha. Encapsulated IP version 4. Source IP address is IP Alpha. Destination IP address IP Bravo. Encapsulated protocol 1, which stands for ICMP. So encapsulated ICMP. And within ICMP data, there is like blah, 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 and sequence number. ICMP echo request. Once again, you need to get familiar and memorize protocols encapsulated into IPv4. ICMP stands for 1. It's quite simple. Most popular protocols, ICMP equals 1, UDP equals 17, TCP equals 6. You also need to memorize ICMP codes, such as echo request stands for 8, echo response states for 0. Different kind of errors, the state is 3. You will see like in traceroute. And then there are subcodes. But we are not talking about this at the moment. We're talking about single ping, just a single ping. As you might see, 3 frames already crossed the network. So Bravo has received ICMP echo request from Alpha. But you know what? Bravo is unable to respond back. Why? Because Bravo actually doesn't know what's the MAC address of Alpha. So the frame number 4 is delivered to broadcast FF, 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 FF from MAC Bravo. And the request is, who has IP alpha? Please tell IP Bravo. And the alpha must respond before communication will happen. So destination MAC Bravo, source MAC alpha, I am IP alpha, MAC alpha. And only then Bravo is able to respond back. So then Bravo builds a frame destined to MAC alpha from MAC Bravo. In this frame, IPv4 is encapsulated. Source IP Bravo, destination IP alpha, ICMP, echo response. So for the very first ping, you need 6 frames to cross the network before it will be completed. You could also pay attention to this. This is destination MAC and source MAC. In IP, this is source and this is destination, which is vice versa. Kind of counterintuitive until you understand why. We don't need to at the moment. The whole idea of this communication is like that. So if you sniff for ERP protocol, you will figure out how many devices are here, even though the firewall is totally blocking everything. I was talking about all of this because of the firewall. So now I'll go back to attacker machine. I don't need Kane, but maybe the reason could be, yeah, like this. I begin sniffing. I select ping 102.20.08. I need to remove the firewall. Sorry. Client. Turn off the firewall. Good. Next, I will clear ARP cache. You can check what's in cache. ARP A, like the command ARP A to figure out MAC addresses in cache. So I don't need the Wireshark to figure out if the computer is alive? I just simply check the cache, and I see that 8 is dynamically responding, so it's alive. So ARP delete everything and ping once again. Stop, go, ping. Now the question why it's not pinging, because I did everything right. Firewall. No, I said okay. So let's stop it. Once again, clear cache. Prepare to ping. Go, go, go. Okay, you see 4 packets of ARP. Resolution both ways. Now talking about communication like this. Something is going on with Windows 10 because probably Windows Update is installing something. But again, let me find my ICMP in here. Not IP address equals this one. Maybe a little bit more clear picture of what's going on. Now this picture looks great. This one. So 2 ARPs, first ICMP, 2 incoming ARPs, the second ICMP, and then ICMPs continue with cached values. This is it. So this is a good picture. This is it for host scanning. Now you know how to figure out the content of the current subnet, how many hosts are there, and remote subnet. Let me describe one more thing about Kali, Nmap, and so on. Yeah, Google this. Nmap, chat. Not as big picture, but you need to memorize it and test yourselves. You will be asked on exam on switches, different kind of switches, a lot of different switches for Nmap. Maybe you need some separate book for Nmap. Now you know what to Google, okay? This one, Nmap chat share, and memorize it. You know, in material, you will find out that you could ask ChatGPT for Nmap switches. But for real exam, you need to memorize them and know why you utilize this switch or maybe that switch. Also, it's recommended to play around with CEHv13. Metasploit we will take on Thursday. And Netscan Tools Pro, you could download it or take from tools and also test how it works. There are a lot of tools. Now we're going to a little bit more complicated stuff, which is TCP communication. You ready? I hope so. So talking about TCP, that's the second step of scanning. Now we know how many hosts are there in the local subnet. We know, for example, 4 victims in this subnet. Next step is to find out open ports. And let me describe what actually port is. In your PC, if you check, for example, Task Manager, if you go to Processes, if you enumerate processes, you will find out that your PC is running a lot of executables and DLLs, a lot of everything. And all of those processes are working in parallel. And your computer communicates with the network in many parallel sessions. So that's why applications request so-called ports. There are most popular, there are two port tables. TCP port table and the UDP port table. Like phone call and SMS message, TCP and UDP are not any the same. TCP is like a phone call. UDP is like a message, text message. If somebody drops you the message, there is no guarantee that you will read the message and respond. If somebody calls you, they want you to respond immediately, and they want to keep conversation up. So you will use conversation in both directions. So this is why TCP works for some specific end user applications, such as web servers, like web servers or web pages. It's a little bit more user friendly. Web pages work with TCP protocol, or say mail protocols, such as SMTP, such as POP, HTTP work with TCP transport protocol. What else? SSH sessions, Telnet sessions, FTP sessions utilize TCP transport. UDP could be DNS simple name resolution performed by UDP. Video streaming could be performed by UDP. Calls could be performed by UDP because they utilize the protocols, application layer protocols built in a way so if you lose some packets, it has less impact on conversation. So impact is minimized anyway. But we are talking about ports. So well-known applications, well-known services, what I'm showing you are services, typically utilize well-known ports. For example, port TCP80, 443. Could we name more ports, please? 80 stands for HTTP protocol. 443 HTTPS. What else? 21.
22, 21.
22. SSH. Something else.
25.
25. SMTP. Or say 3389.
RDP.
RDP. But there is a catch. The same RDP protocol could also preserve 3389 in UDP port table. Or say 53 TCP could be preserved for DNS purposes, for zone transfers. It could be like transfers. Or say 53 DNS name resolution is performed by using UDP. Long name resolution can be performed by TCP, and so on. But in general, if some application utilizes port 25 UDP, those applications are not related to each other. And both port tables are not related to each other. If some application has preserved port 80 in TCP port table, this tells you nothing about this port table. So this is not necessary. Well, talking about well-known ports, let me Google once again. Well-known port, chat. Take the biggest one. For example, this one, and you need to memorize it because you will be asked on exam. So the more ports you know, the better. Then, how it works with multiple applications. Say this is TCP port table. An application boots up, such as ISXZ. I'm just simply imagining this. Internet Information Server reserves port 80 for its needs. In case some other application, such as Apache XZ, starts and also requests port 80 from operating system, because operating system controls this table, it will be denied because the port is already taken. So Apache probably will not start. There could be some application which doesn't require specific port, such as Google Chrome XZ. When it boots up, or when you connect to some website, the communication is bidirectional. So when clients communicate with web servers, it's always bidirectional because you send, say, GET, and you have some HTTP response from IP port to IP port, from IP port to IP port. Chrome XZ can request dynamic range. And operating system says, okay, the port number 49001 is yours. When you open multiple pages in Chrome, could be 49882, 49883, and so on could be yours. And typical web page, there could be up to 100 ports open because you download a lot of advertisements, a lot of pictures from different sources, and you just simply could check the traffic to see how many ports are open within the single tab of web browser. But in this case, when application communicates to a web, it provides the declaration of ports. So it's like I am IP alpha, port alpha, and communicating to IP Bravo port, for example, 80. And the responses, HTTP packets, will get back from IP Bravo port 80 to previously announced IP alpha port alpha, dynamic port. So when you take some specific host, you never know how many ports are open, how many applications are running. If you perform simply test of each and every port, you will be stopped by the firewall because firewall is not stupid. Firewall will recognize the attack. Scanning ports is considered to be attack. So that's why we need to scan ports carefully. Let's figure out how typical connection to a single port may look like. For this, I will utilize Wireshark. So I need some attacker machine and come on, not again. Defender reactivated once again. I need to uninstall it, basically. Scan settings, it's off. Exclusions are here, but still it asks me for action. Okay, I don't want your scans, go away. Okay, this is attacker machine, and I have the web server in my network. So I need Wireshark, I need the browser, and I will navigate to powergym.com. You could do the same, by the way. Am I too quick, or you okay? At least for now. So I have the Firefox in here and Wireshark in here. I will navigate to www.powergym.com. I'm preparing for this. And we'll begin sniffing the network. So sniff, go, stop, that's enough. And what I need to specify in here, because something is going on this attacker machine, because still it tries Windows Update or Defender or something, I will specify the IP address of my victim. IP.address double equals 10.20.212. By the way, as you might saw, I'm playing around with filters. Please make a mark somewhere in your notepad that you need to memorize filters in Wireshark, because you will be asked on exam. All right. May I continue, please?
Yes.
Okay, good.
Yes, definitely.
Okay, good. So where's my attacker? I wanted to drop down the browser. The only thing I need from the traffic are first 3 packets, and that's it. And this is session establishment. First 3 packets. And then the next packet is HTTP conversation, but session establishment is exactly here. As you might see, the length of packets is not big, because this is the phone call. I am establishing a call. What I'm doing within this call, I initiate the connection to the web server. From dynamic port, this is just dynamic port, assigned by operating system. This is well-known port of web server. Windows length is not interesting. This one, the length of the payload is 0. I transferred nothing of value. I'm just simply establishing the connection. I'm exposing my parameters, and this is it. That's why length is 0. In the first 3 packets, I only deliver flags. I deliver flag SYN, receive SYNAC, and acknowledge the second SYN. So SYN, SYNAC, and ACK is so-called 3-way handshake. 3-way handshake, like this. During this handshake, I expose my port, and that's not even it. I will convert a little bit the options. Right-click, protocol preferences, and disable relative sequence IDs. Now it's good. Now it looks much better. This sequence number is totally random from both sides, from sender and the web server. Both sides generate random initial sequence IDs. Then this sequence will be increased by the number of bytes. If you check like get, HTTP OK, and so on, you will see that this is a length of traffic. So this is how both parties analyze the send and receive traffic and figure out if all bytes are received or sent, because this is the counter of bytes. At the same time, acknowledgement acknowledges the next byte. So you are allowed to send the next byte in your sequence. That's why I have exposed my sequence ID, and the receiving party allows me sending the next byte. The same takes place from my side to the server. The server has exposed its randomly created sequence ID, and then I permit sending the next byte when this byte will be available, of course. Because in this HTTP, I am the initiator of the session, so I will send the next packet because of the next packet, not byte. You could find those values in TCP session configuration. So on Ethernet layer, we know MAC addresses and figure out that IP version 4 is encapsulated. On the IP version 4 layer, we make a declaration of IP addresses and encapsulated TCP protocol, TCP-17. 17, what is it? So 6 bytes of MAC addresses, 6 bytes of MAC address, encapsulated type, and somewhere here, 6. One of those 6 is the identifier of TCP encapsulated. And of course, IP addresses are here. You just simply, while I'm drawing, I cannot expand this. You could expand this arrow on your machine. Okay, I will do it anyway. So yeah, this is it. So still, this counter works packet by packet, packet by packet. TTL still works. I'm the sender of the packet, that's why 128. The receiving party will have it modified to 127. Encapsulated protocol 6 stands for TCP, source and in destination IP addresses, and then payload. Payload for IP version 6 is TCP. On TCP layer, we recognize the following values: source port and destination port. Just to mark it once again, ports are the concept for TCP and UDP protocols, not for ICP, not for ERP, not for anything else. Even HTTP is upper level protocol, so it has no concept of ports. Well, window size is how many bytes you are permitted to send without acknowledgement. Because when you talk to your friend by a phone, you talk a lot, and then you need to hear from him. Yeah, I see, I hear you, some acknowledgement. So that's the window size defines how many bytes you send before acknowledgement is required. Next, 1 byte defines 1 byte, 2 bytes defines flags. In this case, flag SYN is set. I want to communicate, and that's it. So this is service byte, which is interpreted by receiving party. SYN ACK means 1, 1. ACK, just simply 1 in here. And this is what you can see in the traffic. And again, no actual payload in HTTP, just simply session establishment. So one of the possible way to scan ports is to perform three-way handshake with the following way, such as SYN to receive SYN-ACK, which indicates the port is open. And then you reset the connection, reset acknowledge, because you will not continue communicating with this port. Just simply, okay, it's open. Good luck. What if port is not open? Let me prepare for this demo. So I'm going to some random port such as 88 and begin sniffing. Go. And nothing. And nothing. In this situation, we consider port is filtered by the firewall because we don't have any response. I repeat my attempts, but there's no response. So the port is closed. And there is one more possible situation. When you navigate to, say, 172.20.208 to port 12345, which is also unavailable, but in a different way, because this is the same subnet. Go, and go, and stop. The picture is totally different. As you might see, as the first packet, I initiate connection to the main controller to port 12345 and receive reset acknowledge, because acknowledge stands for my SYN. I acknowledge that I have received your previous packet. Good. But port is not open by any application. There is no application behind this port. That's why operating system generates reset. Now let me describe once again. SYN, SYN-ACK, reset ACK, port is open. Reset again, because I'm not gonna continue communication. SYN, reset acknowledge, port is not open, because there is no application behind this port. It's not registered. And SYN, and nothing. Port is blocked by firewall. So those are three possible reactions on port scanning. Now let's try scanning ports. We don't have firewall within the single subnet. So I will do it by using several tools. First tool on Windows. It's very simple, well-known tool. If you go to Peter Tools, so if you go to disk, in my case, disk echo, you navigate to Peter Tools, you go to Famatech folder, you will find advanced IP scanner to scan hosts and advanced port scanner to scan ports. Let's do it. I will not install it, I will run it portable. So I select portable version of port scanner, go. And you need to specify two options, the IP address of your victim and the port range. question, how many ports could be there in TCP protocol?
65,532.
Yeah, because of 2 bytes. Good. And the same UDP. Why the scanning is limited to, say, 4,000 ports? Because of the speed. Because if you do it remotely, it's quite slow process. I specify 4,000 because 3389 typically is below 4,000. You could specify more, and that's not even it. If you specify well-known ports, only a limited set of ports will be scanned. If you specify a full range, 1 to 4,000, the full range will be scanned. So, okay, we have multiple victims in here. Lesson should be learned this way. You need to document your findings. So in Notepad, I will figure out that I have 4 victims: 172.20.01, 172.20.07, 172.20.08, and 172.20.208. Because 100 equals Kali and .10 equals attacker. I will not attack myself, so I will attack those 4. Okay, let it be 2008. Let it be full port range of 1 to 4,000. Go. All right. Basically, I have a list of ports open on that victim. This is good. I will document my findings. 53, 88, 135, 139, 39, 445, 464. Well, currently, this is just a list of ports, no more. I don't know what's behind 53. All right, in this case, the application, the port scanner, presented me the output that this is DNS 6.1. But sometimes you can never be sure, such as what is 464? I don't know. But there is some application which is listening on that port. And by this, I need to scan each and every machine. I will scan the router, but will increase the port range till 9,000 because I know there are more ports. Go. Right, so machine exists. '21, 80, 2000. Good. Maybe something else. Yeah. 8728, 8729, and 8291. Something like this. Okay, so I continue documenting my.
Can I ask
Yeah?
you some question?
Sure.
If we are doing like this network scanning, should we be visible or invisible for flow detection on the network?
You're very visible. You're bright like a star.
I know that you are visible, but when you are doing the ethical hacking, you could be visible or you should be invisible.
In ethical hacking, you perform pen test as is. So if your client's firewall or IDS system doesn't recognize you, they doesn't recognize you. They do not. Or say, in ethical hacking, they do not disable any security measures. That's even more. You need to overcome their security measures, countermeasures. So the best choice is to be invisible. But it's not like you come to the company, hello, everybody, we are performing the penetration test. No, it's not like that. You're like new employee and nobody knows what you're doing. Or say everybody knows that you're cashier, then, but actually you're pen tester. Or nobody sees you if you scan from outside and so on. Of course, you need to be hidden from everybody. Yeah, that's true. But I mean, you're bright like a star. In this case, if you sniff this traffic from say, I will install Wireshark on domain controller because I will need it anyway. I just wanted to show you. Oh, yeah, I know. I will perform scanning from Kali and sniff it on Windows 10 because Wireshark is running. So this is done with Pharmatech port scanner. Just an example of application. That's it. Now the next is Kali and map. And map -T4, which specifies the intensity of scan. -A capital, -V, okay, 172, 20, 100. I will show you how it looks like from Wireshark point of view. So where is my attacker machine? Close filter, go sniff, and go Kali. And this is it. Let's check attacker machine. What we see from here, let it be like IP address double equals 172.20.0.100. No. Something's not working. Because 100 is myself. 10. I need to scan 10. Basically, it looks like that. On exam, they might present you the screen like this. And the question, what is going on? And you need to select the right answer. Who is scanning? Who is the attacker? Who is the victim? And what type of scanning is performed as well. So this is how scanning looks like. I will not continue this from Kali because I will not attack attacker. I will attack the router. I see a list of ports. Even more, 22, 23, which were missed by Pharmatech. Now it's scanning services. Basically, you know what? I will stop it because I don't need to scan services. The general idea is of the second step is to scan ports, open ports. Talking about domain controller 208, why not? You see a list of open ports on domain controller. And also, I would like to test web server and email server. So I'm calling this scan type against 1020.0.203 to figure out how many ports are open on 203. I see a few ports such as 53, 110, 25. Okay, good. Maybe something else. Probably not, because of the firewall. We have the firewall in between two subnets. So I don't expect more results. Or say I can try scanning the web server 212, 216, which is also the web server. So I see, yeah, goodshopping.com on port 80, and this is it. The only port open on that machine is port 80. Because all other ports are blocked by the firewall. Is it good so far, please? You okay? Let's do what?
Yeah.
One more exercise is honeypot. How to attract attacker to honeypot. I don't expect you will be able to do it quickly, but let me explain the idea. First, I will switch Kali to DMZ. So in virtual machine settings, I'm going to machine settings and switching network card to CEHv13 to have direct connection to DMZ network. Okay. Count till 5 and relaunch DHCP client, DH client. Maybe this not working. IP address. Yeah, it didn't work. So I will do it in a little different way. I click network connections and disconnect from network and now reconnect to wired connections. Yes, and now I have received new IP address of 10.20.0.100. Okay, good. So once again, how did I do that? I've switched the network card of Kali machine in virtual machine settings. I went to network and switched internal network to DMZ VLAN, and then clicked cable connection and reconnected. By this, I have refreshed my IP address and received new IP address from DHCP. That's first. Second, I will prepare honeypot. I know it's installed already on web machine, on SQL. On SQL machine, somewhere on the C drive. Yes, this is SQL machine. On C drive, it has honeypot. So you just simply go to honeypot.exe and click start. Execute on all adapters. So I have clicked this button. Now I'm listening for incoming connections. And on Kali, I will call nmap to this machine 10.20.0.2.16. Go. Stop. That's enough. I see hundreds of open ports on that machine. Not hundreds, but quite a lot. I could try interacting with those ports, such as telnet 10.20.0.2.16, say port 25, which could be SMTP. And it presents some interaction level. Hello. Says hello. Mile from blah, blah, blah. Okay. And now I see that this is honeypot. Because I typed mail from and the expression, which never could be recognized as email address, but it says action OK. Well, there are some defensive measures on SMTP service which accept any inconsistent addresses and just simply drop your message to the recycle. Yeah, could be like that. But what I wanted to show you that SMTP is actually not running on this machine. It's honeypot running on this machine, which attracts attackers. While I'm interacting with faked SMTP, an admin is already notified that somebody has connected to port 25. But do I see this? I don't see view details. And that's details of interaction. So I see what attacker is actually doing on that machine. This is it about honeypot. The general idea is if you place honeypot in your DMZ network, not necessarily DMZ, you could easily catch an attacker by non-standard ports. Because say in my production network, SMTP only exists on SMTP server, not on honeypot machine. In case somebody connects to my port 25 on honeypot, this is an attack. Of course, random services are simulated in here. Any questions so far, please? No? If not, let's have coffee break. It's time for coffee break. Is it good? Okay, see you in 20 minutes.
2.
20 minutes. Oh, do you? Good.
Yeah.
Still okay to continue?
Yeah, let's do it.
All right. All right. Checking my checklist. Yeah.
Peter, can I ask?
Sure.
About that program, Honeybot. It will create IP address for that Honeybot, or because there was like 216 or something. So I suppose that it will create a separate IP address for that honeypot.
You mean in this demo network or real network? For this virtual network?
It depends. Yeah, for
Okay.
this virtual network.
In this virtual network, you just simply launch it and execute it, and it will listen on 216. It will just simply listen for incoming connections. In the real network, you better have dedicated virtual machine for this. Anyway. All right, so let's go to scan types. What you just saw in port scanning was so-called full open scan. When you issue all set of flags, all set of packets, and the firewall is aware of this. Firewall can easily track you down and disable your communication. So this is not like to be done in protected networks. When network is not protected by the firewall, okay, it's going to work anyway. But sometimes you need to hide from being detected. And I will try to scroll quickly to types of scanning. This is host discovery, not port discovery. So ways to discover live hosts. Now this is port scanning techniques. Like full open scan was this one. Half open as when you send the first SYN and never respond anymore to the response. You never respond to response. So you never end this sequence in the third handshake. So just simply initiate scan, receive some answer, and that's it. And forget about this. And the firewall may consider that this is some timeout or something, not necessary to be port scanning. Or say inverse TCP flag scan, you set flags such as flags which are not seen or acknowledged, or say Christmas scan, or say null scan. No any flag set, just simply send a packet which looks like initiating traffic to you to target machine. There is no flags, any flag set. So what do I respond? Yeah, the technique is like you send some bullshit to the victim. In case port is not open, the answer will be reset anyway, because the port is not open. There is no application. But if there is the application never knows what to return back. So what should be the response on random flags? I don't know. And then by this silence, you recognize that the port is open. Or say acknowledge. You send the empty packet with acknowledge flag on. You acknowledge something. What? What do you acknowledge? Still, application has nothing to send back, and by this silence, recognize that port is open. But if reset comes back, okay, port is not open. This one could be complicated a little bit. IP ID. So I'd like to describe this. So there's the victim, some server machine, victim. There's the workstation, which is the legitimate workstation, but we will utilize it as a zombie. And the attacker is here. But attacker cannot expose itself directly. No. So there could be two options. You don't want to be detected, or you don't have connectivity. Say this is the remote subnet, and you are in this subnet, and say this packet could be accepted from zombie machine, but not from your machine. Or this is like company manager machine, or company CEO, or stakeholder machine. As you might know, for top level management, there are always, like in most cases, not always, but in most cases, no limitations. Because if something is not working for stakeholders, they'll fire, and that's it. So in many companies, the top management works without restrictions. That's why you could try utilizing their computer for further attacks. Okay, so anyway, how IP ID or idle scan works. First, you ping zombie. So you send ICMP packet, ICMP echo request, receive ICMP echo reply, and find out IP ID. So ping zombie and find IP ID. The second step, you send spoofed packet to victim from zombie name. It may look like this. So you spoof sender IP address. And then there could be some reaction from the victim. If port is open, victim, okay, so you send SYN. Victim may respond SYNOC. But zombie has not requested anything. So zombie wonders, what's going on? What's SYNOC? I don't know. Reset. For this action, zombie spends one packet. And you could easily figure out this by re-pinging once again. And again, find IP ID. If IP ID has increased by 2, it means that zombie has spent packets somewhere. If port was not open or blocked, so the incoming packet would be like reset. Packet from server, reset. And zombie will not reply reset on reset. So zombie will not spend a packet. And then IP ID will be increased by 1. So by this technique, you try to figure out if the port is open on victim side by trying to force zombie spending one more packet. And then calculating IP ID, you will figure out if the packet was spent or not. Let me show you how to spoof packets. This is not as hard. Basically, that's very elementary. For this, on attacker machine, I will install from tools. From peer tools, I go to CH course folder. So this is attacker machine. I'm going to peer tools. I'm going to CH course. And there is Colasoft packet builder. I will install it. Okay, good. It's done. Go. Now, what about faked packets? What specific faked packet I will create? SYN packet. So I will insert packet of TCP. Okay. And I need to fill few fields in this packet. Anyway, this should be Ethernet layer, such as destination MAC address and source MAC address. I will spoof IP address, not MAC address. So in this case, destination MAC address is like the main controller. So ping 172.20.028 to figure out the main controller's MAC address in ARP cache. ARP-A. So I see the MAC address of the domain controller. I will just simply copy paste it and replace dashes with columns. Well, this is not scripting in this case, I understand. This is not like Python scripting. Good. Question is general idea. Source MAC address, I will specify my MAC address. For this, I will check ipconfig all, figure out the MAC address of the network card. This is a good idea to understand that MAC address is the property of a network card, not computer, a network card. So for this network card, MAC address is this one. As you might see, or you might guess, those MAC addresses are customized. I have customized them before the course. It's simply to be done in virtualization. If you click Mesh in Settings of Virtual Machine, if you go to Network, if you expand what? If you expand, where's my network? Oh yeah, it's disabled because the computer is running. When you turn off the PC, you could specify customized MAC address in here. This could be a little bit tricky because, as you might know, MAC addresses are split by two halves. I would like to show you this in Google. This one. So vendor specific card, not card, specific address, 24 bits and more, 24 bits more for random device specific within this vendor. Vendor could be Hewlett-Packard, Dell, Samsung, Huawei, whatever, Apple. For me, when you perform penetration test, it's a good idea to reset MAC address of your PC. Again, MAC address is not the property of PC, it's a property of network card. So I suggest you resetting MAC addresses of all network cards on your computer. On physical machine, this can be done like this. I'm going to Control Panel probably. Where's my Explorer? A second. I'm going to Explorer. Up one level up. Control Panel. Network sharing center. Adapter settings. My network card, which is currently not connected Oh yeah, wireless is connected. Properties and configure network card. In advanced, you may find locally administered address. Do we have for wireless? I suppose no. Yeah, I don't see this option for wireless card. Interesting, but say for cable connected card properties, you go to configure and in advanced, you will see a locally administered address, this one. So you could specify another MAC address for your card. So you take like something like mobile phone from Samsung or maybe from Apple, and let admin thinks that you're hacking this network from mobile phone, which is not necessary to be true. Talking about duplicating MAC addresses from somebody else, I believe this not working normal way. So my suggestion is still create MAC address based on faked vendor, and then random serial number within this vendor. Okay. Encapsulated protocol, IP version 4, good, that's enough. Source IP address, destination IP address, time to leave, TTL 64, so it's not Windows, okay, good. Then I'm not talking about fragmentation this time, but say encapsulated protocol 6, good. Source address, 172.20.100. Let it be like from Kali, and Kali will be my zombie or whatever. And 172.20.208 is my victim. Yeah, that's enough. SYN flag 1, so it's on. Nothing else needs to be customized. There is nothing important in here. Flags, acknowledge source port, destination port, say 445. Source port, something random, such as 4000. Well, this looks great now. So I have specified MAC addresses, IP addresses, ports, SYN, almost ready. But before this, I need to return Kali back to LAN network. So mesh and settings, network, LAN, okay, and reconnect the network. Disconnect and connect. Checking IP address, 172.20.100. Okay, good. So attacker is attacker, zombie is Kali. Why? Because I have Wireshark in here. That's the only reason. To sniff for traffic. Then I will try to connect to by using spoofed IP address to the main controller, and we'll sniff for response. So Kali is sniffing IP address, ip.addr double equals the main controller, and go send packets via this network card. No, that network card. Okay, start, stop. And that was exactly what I expected to see on my Kali machine. So as you might see, the attacker was Windows 10.10, but it sent the spoofed packet like from 100, and I see it in traffic. And 208 has responded back to 100. So that was, this is not MBSS continuation. This is SYN, just simply SYN, as you might see from flags. and the response was CNAC. But I have never requested, the Kali has never requested this communication, so Kali responds back with reset. The general idea of this exercise was to show you that spoofing parameters in IP costs nothing. This very simple logical process, but what's more complicated to support the whole conversation. So you need to script it. You can import some previous traffic saved from network monitor, and then import, modify it, and resend it. Yeah, maybe you will find something interesting. Maybe you will achieve some good result. But the idea is that you could spoof a lot of parameters in here, and nobody can stop you. That's it. Next, playing with customized packets could be useful in different scenarios. Let me show you an example of scenario and MikroTik router. First, I will try remote desktop to an email server, 10.20.0203. Can I connect? I think no, because if we get back to the result of scanning, where is my scanning? Oh, I have closed it, probably. Okay, sudo su. Oh no. There is network scanning in here. Oh yeah, there it goes. That was a scan result of 2003. As you might see, the only open ports are 53, 110, 25, and RDP port is not open because it's blocked by the firewall. So if I go to RDP on that remote subnet, well, that's nothing. Just nothing. And then I will perform some little trick. Ping 10.20.0203 and length of the packet 128. So I'm pinging it with 128 bytes. I don't remember which exactly number, 128 or 100. I will try. Remote desktop. Oh no, I failed. Let me try 100. So this is the payload length, 100, and I'm connecting to, oh yes, and you see the remote desktop. Good DMZ network. And what's that? This is called, this technique called port knocking. You knock, knock, knock. By a very special knocking. Knock, knock, no, no, knock. And then the port is open for you. I will show you how it works. In victim machine, victim machine. On victim machine, I have Winbox software, which controls MikroTik. I'm connecting as limited user. And exactly this one, exactly this rule. On the firewall rules, if I see the source address belongs to LAN, interesting that destination address is not here because I just simply forgot about this. But anyway, if someone from network 172.20 pings with packet size 128, which actually is the total packet size, but this is it provides 100 bytes length of payload of this ABCDEFG. then action is add source IP address to special allowed RDP address list. So if you check address lists, you will see that allowed RDP is here still for 8 minutes is here. And Windows 10 is added to this list. And then in rules, RDP will be allowed for source allowed RDP. So by pinging, you add yourself to this specific address list. And then for this address list, RDP is allowed. So interesting part of hacking. Not hacking. I don't know if this is hacking or not. I just wanted to show you the idea of customizing packets. So custom packets could be quite useful sometimes. Next. Checking what's next. This is your homework. Let me put the exclamation mark in here, even 2, because on exam, they will ask you on different types of port scanning. So you need to read your material and learn the difference between, say, acknowledge scan and null scan. You need to memorize this. Next.